Hi all. All right. So today we're going to start off this new series on database design and how it all works together. Now the idea behind this whole thing is that I want people to understand how to design a database. I want interviewees, I want employees, I want just tech people to know how to design a database, which seems to be a very hard thing nowadays. So the first thing is the prerequisite for this whole course is just that you should know some DBMS concepts. We will be brushing them up. Yes, we will be brushing them up, but still, if you know them very well already, it will be quite better. We will go through some concepts first. There are like 8 to 9, I think, concepts that I have in my mind before we actually go into database design. And when we sorry, when we go into database design, we will leave everything aside. We will just design different databases. We will just design databases for different solutions, different architectures, different businesses ideas that we will have. Okay, so let's kick it off with DBM keys in DBMS. The first and the foremost key that is practically used in DBMS is called a primary key. Okay, so it will be also be known as a primary constant, you can say. Let's say we have a student table which has an ID, which has name, which has address, okay, which has phone, and some more details. Let's say I'll just draw a line over there. Now a key such that a key such that when used to search will give all the details of a student record uniquely to us will be known as a primary key. And you can think of it as a key to a lock. Let's say we have a cupboard, right? We have a cupboard and we have a lock over here. Now the key that we will be putting into that lock will be the only thing to identify everything inside the lock, inside the cupboard. We could have clothes, we could have wallets, we could have accessories, we could have documents, we could have so many things inside the lock, inside the cupboard, which is closed unless you have the key. If you don't have the key and you just know the document name, you can't find it. If you don't have the key and you don't know the you don't have the key and you know the clothes that you have, you can't find them. But still, this is a very vague example. Don't think of it like that. It's just something I wanted to throw out there. So that's your primary key, which can be used to uniquely identify each and every single record in a table. They will all have a unique primary key. Okay. Now candidate keys can a table can have multiple candidates keys. Okay. Now this is just an information related thing, and one of them will be primary. So for example, you can see over here we have phone and email as well, right, in the table, which both would be unique to each and every student. They have to be, right? And we have ID as well, let's say. All three of these fields can be used to uniquely identify a record in the student table. It's just that we have picked ID for doing our job. That's it. You could have picked email as well and phone as well. Normally people don't pick up something that is text based or varchar, let's say text based, a string, right? Because simply because database takes a lot of time to run string based operations. With that in mind, let's go to super keys. Again, an information related thing only. All right, so set of candidates, that's all it is. This is again a theory part, you can say. So let's say there is a set that we make, all right, email and ID. This whole thing will be a super key, called a super key. You can't create super keys in database. You can create composite keys, you can create indexes like that, you can create indexes like that in that sense, but you cannot create something called a super key in the database. Coming to alternate keys, let me draw a straight line. Okay, coming back to alternate keys. Now you can read over here, any candidate not selected to be a primary key. So in our case, you can see these are candidate keys, phone, email ID. Two of them, which are phone and email, were not selected to be primary keys. In that sense, we know that in our table, phone and email are marked as alternate keys. Foreign key is simply that links something to another table. So let's say we have this student table, right? And we want to link it to a class or a subject that their student is taking, or their mark sheet, or their attendance. We will pass, let's say there's an attendance table, okay? We will pass the SID, which is the primary key. Specifically, we will pass only the primary key to the another table, or a relationship table in between. Could be a relationship table as well, depending on the kind of relation the two tables have. And in that sense, you will know that this SID over here, the student ID, either here or here, will be called as a foreign key. So we know that this attendance record of some date and some attendance true or false belongs to which student. And the same with the relation between student and attendance. That's all. Moving on to composite keys. Now composite key, as I said, you can create composite keys in databases. Composite key is simply a cluster of keys, that's all. So it could also, you can refer as non-cluster keys, non-cluster index. Maybe you can make this thing on composite keys only. So composite keys are any primary or candidate keys which together we are making a key in the database on a specific table. So let's say we have ID already as a primary key, okay? Now I want to change something. I want to make the phone and email, a combination of these two, a key. A combination, that means what I am going to say is this combination for each every record will be unique. There won't be a record called abc.com and 123, let's say, phone number. This will not duplicate. This can happen 456 123 and cde.com. This can happen, but these cannot be duplicated. So this will become a composite key for us. Unique key is simply that we want a column to be unique in our table. Let's say we want the phone number. By default, this will not be unique in our table. We have to set a constraint. So we will have to go into our SSMS, our workbench, wherever we are creating the query, right? PJSQL, PJadmin. We have to give it a unique constraint. That's all. Which says that each and every record should have a different phone number, and by default it is a not null. It has a not null this thing as well. There will not be null parameters in unique keys at all. Okay. Surrogate keys, again something informational. This is again, unique keys are practical, composite keys are practical, surrogate keys are informational thing. System generated keys, no meaning at all. Let's say there are some keys. Let's say you generate ID, right? Generate ID, which is auto incremented. So each record that you add, the ID will go 1 2 3 4 and so on so forth. But we are not using ID at all. I'm using email to identify a record. Then this thing doesn't have any meaning anymore, right? Then this will be called a surrogate keys. It's there, but it doesn't have any meaning. It's there, we can use it, but it doesn't have a significant meaning at all. Natural keys are any data that is coming from a real world object. For example, we have email, literally, right? We have phone number, right? We have address. All of these things are coming from real world data. This in our database. It's not like we are generating in our database. It's not like we are putting it out of our own mind. We want to put it in our own way like that, right? It's not like that at all. It's just email coming from your mailboxes, your websites, phone number coming from your cellular devices, and address coming from your light bills, your address proofs, and such things like that. And again, this is the information key. This is just something to know for you, not something that you can implement in your database. And that was the video, guys. Next time we will start looking into functional dependencies and how they work in database and some part of normalization as well. Thank you for your time. Hope you like the video. Leave me a comment if you want me to address anything specific, and let me know about your views.